Okay, index notation for part A, the answer will be A to the power of 5. Yeah. Hey, I thought I saw Rian just now. Where are you sitting there? Okay, A to the power of 3 times B to the power of 2. For part B, then C power 3, D power 2, and E power 2. Alright? Alright or not? Okay, find the value. Next one, 5 power 3 times 2 power 4. 2000. Part B, 7 square times 2 power 5 minus 7 times 2. 1554. Right? Yes? Question 1 wrong. As in you all don't want to write the times, is it? Can. AB square. Can. Same thing. Okay, next one. 8 power negative 1 plus 4 power 3. So if you look at the way I do it, am I using a lot of brain power? No, it's just use calculator only. Okay, so 64 and 0.125. How much is 0.125? Do you know how to convert from this one to mixed fraction? How? SD? Yeah, press SD there, get 64.125. Huh? Shift. Oh, thank you. I didn't know that. I really didn't know that. So apparently you can press Shift and then SD. Thank you. I've always been multiplying, then I subtract. So take a lot of time. But yep, this is a very good way. Next one, 5 power 0. Do you remember how much is 5 power 0? How much? What's the value of 5 power 0? 1. It is 1. So if we work it out, it is actually 1 divided by 2 power negative 3. How much is 2 power negative 3? 1 over 2 power 3, right? This 2 power negative 3 is the same as 1 over 2 power 3. Same thing. Then when I have a divide, it is actually the same as 1 times 2 power 3 over 1, which is 8. But if you are lazy to do all this, type in your calculator. 5 power 0 divided by 2 power negative 3. And you get 8. Next, writing in standard form. So let us recap. For standard form, we need to find the decimal point first. So I would like to do part B first. Since part A, no decimal point. Let's start with part B. That's the decimal. And I am going to jump in a direction such that I will end up with a number greater than or equal to 1, but less than 10. So right now this is a very tiny number. I'm going to jump to the right. 1, 2, 3, 4, and 5. So if my decimal point ends up between 3 and 2, my value will be 3.25. But obviously these two numbers are not the same. In the original question, it is a really tiny number, 0.000325. Whereas what I've written down is 3.25. It's much bigger. So I need to continue by multiplying it with 10 to the power of, I jumped 5 times. 3, 1, 2, 3, 4, 5. I know it is going to be a 5 on top, but is it a positive or negative 5? Okay, so how do we check? How do we tell? Now you think about it, 10 power 5, is it a very big number? Very, very big. is 1 with 5 zeros. It's a huge number. This huge number times 3.25. The answer very big, right? So it cannot be positive. Then if it is negative, it will now become a very tiny number. And we can verify our answers using our calculator again. 3.25 times 10 to the power of negative 5. 0.0000325. So now we go on to part A again. Identify the decimal point. This is a whole number. The decimal point can be introduced by you at the end of all the digits. So the decimal is over here. Again, we do the same thing. We want to rewrite this. We want to move the decimal point until I get a number between 1 and 10. So I have to jump to the left this time. 1, 2, 3, 4, 5 times. And my answer will be, my number is 7.94872. Then you look at the question again. It's a very big number. 872. It cannot be equal to 7.94. So I still need to multiply this by 10 to the power of, we jump 5 times. So I'll write down at the top 5. Then does this make sense? 10 power 5 is a very big number. It makes sense. You can verify with your calculator. 7.94872 times 10 power 5. So you get back exactly the same number. Now question 5. Can ignore the first sentence. They just want you to write this in standard form. Same thing, jump. Decimal point, 1, 2, 3, 4. This time you jump 4 times. So 5, 6, 7, 8, 2.52 is the same as 5.678252, 1, 2, 3, 4 times 10 to the power of 4. This is the answer. And the last page of your homework, over here, question 6. Again, write in standard form. First one. So when you are able to do all the jumping, you know the steps already. You can just write 7.65 and then just copy everything down. Then count how many times you jump. 1, 2, 3, 4, 5, 6 times 10 power 6. For part B, I know that after jumping, it is going to be 1.25972. Now the question is multiplied by 10 to the power of 1, 2, 3. Then 10 power 3 is actually 1000. It's a big number. So I need to include a negative. Here are my answers. It shouldn't take you more than 5 seconds to do each of these questions, as long as you can follow the steps. Oh, 4 SF. Oh, thank you. So the first one, we round it off to become 7.653 times 10 power 6. The second one, 1.260 times 10 power negative 3. Why? Is the applause for my very good work? I hope it is, huh? Now question 7. Calculator work again. So the first answer will be 1.442 according to my calculator times 10 to the power of 1, 2, 3, 4. And they want it in 3SF. Round it off, 1.44 times 10 power 4. Part B, 2.8 times 10 power negative 5. So this is 1.288 times 10 to the power of 4. Round off to 3SF again, 1.29. How many 0.003 cm are there in 45 meters? So if this is 45 meters, how many 0.03 cm are there? What do you think should be the step if I want to find a total number of 0.03 cm? So let me give you a strategy. We can change the numbers to our convenience to have an idea of how we are supposed to do it. For example, if it is not 0.003 cm, 0.003, if it is not 0.003, if it is 1 meter, how many 1 meters are there in 45 meters? What will you do? Or rather, what is the answer? Total 45 meters, how many of 1 meters are there? How many? Just 45 lah. We take 45 divided by 1. You get 45. What if I ask you, how many half meters are there? How many of a half meters are there inside 45 meters? So what you will need to do will be 45 meters divided by half a meter. And we get 90. So we use some numbers that we are comfortable with to get an idea of how to do it. So now instead of half a meter, instead of 1 meter, we need to use 0.003 cm. Make sure the units are the same first. Do you want to convert 45 meters to cm, or do you want to convert 0.003 cm to meters? What's your preference? Meter to cm? Easier, right? Okay, this is the same as 4500 cm. So the answer will therefore be 4500 divided by 0.003. Now all these are in cm already. You get our final answer to be this is our answer. Very big number. You should be using 4,500, not 45, yeah? So we get answer in standard form. 1.5 times 10 to the power of 1, 2, 3, 4, 5, 6. Okay, last question. How many 0.2 grams are there in 12.4 kilograms? We expect the number to be very big again because 0.2 grams is really small and 12.4 kg is a lot. So the answer is simply 12.4 kg is the same as 12400 grams. You just need to multiply by 1000 to get a value in grams. Now we need to divide 12400 divided by 0.2. $62,000, which is 6.2 times 10 to the power of 4, and that's our answer.